Okay, here are your solutions for the second mini assessment. So the first question, expand and simplify 2x minus 4 minus 3x minus 5. So expand and simplify, we do it step by step. First we're going to expand the brackets and then we are going to simplify it down. And it's really important here to be super careful of your negatives, okay? This is the bit that most people on this question would trip up on. Be really careful with your negatives as you multiply out the brackets. So multiply out the brackets, everything on the inside, multiply by what's on the outside. So 2 times x is going to give you 2x. 2 times negative 4 is negative 8. Then when you got here, you've got negative 3. So you're multiplying everything inside the bracket by negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15. So that's the expand part done. Now we need to simplify. So add the like parts. We've got 2x minus 3x is going to be negative x. Negative 8 plus 15 is 7. So your answer is negative x plus 7. Okay, your first mark is for correctly expanding at least one of the brackets. And your second mark is an answer mark. Question 2. The diagram below shows a triangle and a square. The perimeter of the square is 12 centimetres. The height of the triangle is double the base of the triangle. The area of the square is the same as the area of the triangle. Find the height of the triangle. So going to work through each bit of information. So the perimeter of the square is 12 centimetres. Okay, so what do we know about a square? We know that every single side is equal. So if this side is x, this side is x, this side is x, and this side is x. We're told that the perimeter is 12, so we find the perimeter by adding up all the sides. So that's saying x plus x plus x plus x, or 4x, is equal to 12. So using that, we can find the length of one side, divide by 4, we get x is 3. So each side of this square is 3 centimetres long. So we've used that bit of information. Next bit, the height of the triangle is double the base of the triangle. Okay, so our next bit of information is about our triangle. The height is double the base. So if we call the base y, the height is going to be double that, which is 2y. Okay, so now we've used that bit of information. Next bit, the area of the square is the same as the area of the triangle. Okay, so the area of the square, can we find the area of the square? We can, because we've got the sides. Okay, so area of a square is the base times height. So 3 times 3, which is 9 centimetres squared. And now the area of the triangle, okay, we're told is the same. So the area is also 9 centimetres squared. Now, what do we know about the area of a triangle? Well, we know that the formula for the area of a triangle is a half times the base times the height. And we're told that that is equal to 9 centimetres squared, okay, because our triangle has an area of 9. So now going about solving that, what I'm going to do, multiply each side by 2 to get rid of that half, and we get base times height is equal to 18 centimetres squared. Now what do we know about the base and the height? Well, we know that one is double the other, so if we call the base y, then the height is going to be 2y, so we can say y times 2y is equal to 18. Or 2y squared is 18. Now solving that, okay, I'm going to bring it up here, 2y squared is equal to 18. So divide by 2, you get y squared is equal to 9. And then square root each side, you get y is equal to 3. So we've used that. What do they actually want to know? They want to know what the height of the triangle is. So we've worked out y, which is the base. So the height is going to be double that, which is 6. So the height is 6 centimetres. So your first mark here is a full method to find the area of the square. So dividing by 4 and then squaring it. Your second is here for setting up an equation or setting up a method to be able to find the area of a triangle. And your final mark is an answer mark. Question 3. The diagram shows a block of metal on horizontal ground. The base of the block of metal is a rectangle 30 centimetres by x centimetres. The block exerts a force of 4,500 newtons on the ground. The pressure on the ground is 3 newtons per centimetre squared. Work out the value of x. Okay, and for this question, you have been given the formula: pressure is force divided by area. Okay, some people might know it better in sort of triangle form. So, what information have we got? Well, we've got the force and we've got the pressure. Okay, so if we've been told the force and the pressure, we can work out the area. Okay, the area is going to be the bit of the block that is in contact, so the area of this rectangle on the base here. Okay, so we're told that pressure equals force over area, and we can rearrange that to say that area is force divided by pressure. Okay, or if you're using this method, we're trying to find area, so you're going to do force divided by pressure. So let's put in the values we've got. The area is going to be equal to the force, which is 4,500 newtons, divided by the pressure, which is 3 newtons per centimetre squared. So the area is going to be 1,500 centimetres squared. Now from there, what are we trying to work out? We're trying to work out the value of x. So we have got this rectangle. Okay, as I said, the base of our block is going to be a rectangle that's in contact with it. So that is a rectangle like this with 30 centimetres base and x centimetres height. And we know that the area of this is 1,500 centimetres squared. So working backwards to find what x is, we can do 1,500 divided by 30, which is 50. So our rectangle is 50 centimetres tall, so x is 50. Okay, your marks here, your first mark is for dividing the force by the pressure. Your second mark is for a method to find the side, so dividing the area that you've got by the side here, and your final mark is an answer mark. Question 4, expand and simplify root 3 plus 4 brackets 2 root 3 minus 5. Okay, so this is a simplifying surds essentially question and a bit of expanding double brackets. So whatever method you like to think of for expanding double brackets, I like to use FOIL, first, outer, inner, last. Okay, so multiplying the first two terms, we're going to do root 3 times 2 root 3, which is going to be, well, root 3 times root 3 is just 3, times 2 is 6. Then we're going to do the outer, so root 3 times negative 5 is going to give us negative 5 root 3. Inner, 4 times 2 root 3 is 8 root 3. And last, 4 times negative 5 is negative 20. So we end up with 6 minus 5 root 3 plus 8 root 3 minus 20. So simplifying that, okay, we're going to add our numbers to our numbers, our surds to our surds. So 6 minus 20 is minus 14, and negative 5 root 3 plus 8 root 3 makes 3 root 3. So answer is 3 root 3 minus 14, or minus 14 plus 3 root 3. Okay, your first mark is for correctly expanding the brackets, having at least 3 of these terms correct. And your second mark is for correctly simplifying it. Question 5. There are 6 coins in a bag. The value of each coin is shown below. £2, £1, £1, 50p, 50p, 50p. Laura takes at random a coin from the bag and keeps it. Famida then takes at random a coin from the bag and keeps it. Calculate the probability that Famida's coin has a greater value than Laura's coin. So a probability question here. Couple of things to note, okay? Laura takes the coin and keeps it. So it's what we call conditional probability, because when Famida goes to take a coin out of the bag, there's going to be less coins in. So the probability of picking each coin is going to change from when Laura does it to when Famida does it. So there's different ways of going about answering this question. I'm going to do it using a probability tree. Okay, because a probability tree is a really, really sort of simple way of showing and calculating different probabilities. So 3 different possibilities. I'm going to first look at Laura. So when Laura gets to the bag, she can either pick a £2 coin, a £1 coin, or a 50p coin. Okay, so I'm going to put that at the end of my first set of branches, £2, £1, or 50p. Now, what is the probability of each of those? Well, the probability of her getting £2 coin, well, there's one £2 coin out of a total of 6 coins, so it'll be 1/6. There's 2 £1 coins, so that's going to be 2 out of 6. There's 3 50p's, so that's going to be 3 out of 6. Now, I'm not going to simplify my fractions, okay, because that's going to make things easier later on when we might have to add fractions. If your denominators are all the same, it makes things a lot easier down the line. Okay, so now we've got to think about Famida when she takes the coins. So if Laura picks out a £2 coin, from there, Famida can't pick out a £2 coin. It's impossible. Okay, but she can pick out a £1 coin or a 50p coin. Okay, why is it impossible to pick out a £2 coin? Because Laura took out the only £2 coin. And if Laura's kept that £2 coin, Famida can't pick it out. So she can either pick out a £1 or a 50p. Now, Laura's got that £2, so we've only got 5 coins left. So the probability of picking a £1 is going to be 2 out of 5, and the probability of picking 50p is going to be 3 out of 5. Okay, then we say, right, what happens if Laura picks out a £1 coin? Well, if Laura picks out a £1 coin, then Famida can either pick out a £2 coin, a £1 coin, or a 50p coin. Okay, and with that, working out the probabilities, well, let's say Laura's got that £1 coin. So the probability of Famida picking out a £2, well, there's 1 out of 5 coins, so it's 1 out of 5. There's only one £1 coin left, so that is also 1 out of 5. And there are 3 50p's, so that is 3 out of 5. And then finally, if Laura picks out 50p, okay, Famida can then pick out either a £2 coin, a £1 coin, or a 50p piece. And the probabilities of those, well, if she's got a 50p, again, there's only 5 coins left, one of which is £2, so that's going to be 1/5. 2 of which are £1, which is going to be 2/5, and 2 of which are 50p's, so that is also going to be 2/5. Okay, so now we've set up our probability tree. We can start thinking about calculating using it. So, we want to know the probability that Famida's coin has a greater value than Laura's coin. So in which situations will that happen? Well, if Laura picks out a £2 coin, then Famida's definitely going to have a smaller value. So none of those situations. If Laura picks out a £1 coin, then Famida would need to pick out a £2 coin in order to have a greater value. If Laura picks out a 50p, then if Famida gets either a £1 or a £2 coin, then she's going to have a greater value. Okay, so there's 3 different ways in which Famida will have a coin of a greater value than Laura. So now let's work out those probabilities. So the probability of Laura picking £1 is 2/6, and the probability of Famida picking a £2 after that is 1/5. Okay, remember you multiply as you go along the branches. I'm going to do that down here actually. So the probability of that happening is 2/6 over 1/5. Multiplied by 1/5, which gives you 2 out of 30. Then the probability of Laura picking 50p is 3/6. Then Famida picking £2 is 1/5. Multiply those together, we get 3 over 30. And finally, Laura picking 50p, 3/6. multiplied by, for me to pick in a £1, which is 2/5, gives us 6 out of 30. Okay, so the possibility of any of those happening, we're going to add them together. Okay, so you add between the branches 2/30 plus 3/30 plus 6/30. Okay, and you can see now why I didn't simplify any of my fractions, because we've automatically now got the same denominator for each one. So add them up, 2 plus 3 plus 6 is 11. So the probability is 11/30. Okay, so this is a 3-mark question. Your first mark is for working out one of these probabilities. Your second mark is for having the 3 of them and trying to add them together. And your final mark is an answer mark, so getting 11/30. Okay, question 6. Show that 20 to the power of -3/2 can be written in the form √5/a, where a is an integer. You must show your working. So remember, integer is a whole number, so we've got to make sure our denominator is a whole number. So we have 20 to the power of -3/2. Now the first thing we're going to say is, right, that's a negative power. What do we know about negative powers? They become reciprocals. So that is the same as 1/20 to the power of 3/2. Now 20 to the power of 3/2, well, that is the same as saying 20 to the power of a half cubed, okay? Because a half times 3 gives us 3/2. So it's the same as saying 20 to the power of a half cubed. Now what does 20 to the power of a half mean? That means the square root of 20, all cubed. Okay? But obviously we can see in our answer we want something to the √5, not in √20. So let's try and simplify that third. So √20 is the same as √4 times √5. So we can say that is the same as 2√5 all cubed. Now 2√5 cubed, okay, that means 2√5 times 2 times √5 times 2 times √5, okay? You're doing 2√5 multiplied together 3 times. Now, what is that going to be? Well, if we multiply the 2's, 2 times 2 is 4 times 2 is 8. Now, √5 times √5 is 5 times √5 is 5√5. So we end up with 8 times 5√5, which is 40√5. Okay, so that is the same as 1/40√5. But now we still haven't got it in the way we want. We're getting closer because we've got a √5, but we don't want a third on the bottom. We want to rationalise our denominator. So to rationalise the denominator, multiply by your third value. Okay, whatever you do to the denominator, you need to do to the numerator. So we multiply them both by √5, and we get √5 over 40 times √5 times √5 is 5, which is equal to √5 over 200. Okay, so A is 200. So this is a 4-mark question. Your first mark is for using the reciprocal. Okay, so writing it as 1/20 to the power of √3. Your second is for knowing that 20 to the power of half is the square root of 20. Your third is for simplifying the third and trying to rationalise your denominator. And your final one is an answer mark for 200. Okay, and the last question, question 6. The diagram shows a circle centre O. AB is the tangent to the circle at the point A. Angle OBA is 30 degrees. Okay, so O to B to A is 30 degrees. Point B has coordinates 20, 0. Point P has coordinates 3, P. Find the value of P. So, AB is a tangent to the circle at the point A. So it meets the circle here. And what do we know about tangents and circles? We know that the radius and the tangent meet at 90 degrees. So here we've got a right angle triangle. And we know that this length here is 20. And we know that this angle here is 30. So we can actually work out the radius of this by using trigonometry. Okay, we've got a right angle triangle. We've got the opposite is the radius and the hypotenuse is 20. So we can say sine 30 is equal to the opposite divided by 20, or the radius is equal to 20 sine 30. Now this is a non-calculator paper, but you should know the exact value of sine 30. The exact value of sine 30 is a half. So we have 20 times a half, which is 10. So the radius of our circle is 10. Now how's that going to help us? Well, we know that this point here is 3pp. And we know that the formula for the graph of a circle is x squared plus y squared is equal to the radius squared, okay, if it's a circle that's centered around the origin. Well, x squared at this point is going to be 3p squared. Y squared at this point is going to be p squared. And the radius, well, we worked out what the radius is. The radius is 10, so the radius squared is going to be 100. Okay, so if we substitute the values that we've got in, that will help us find our value of p. So 3p squared gives us 9p squared, plus p squared is equal to 100. So we get 10p squared is 100. So p squared is 10, and p is root 10. So your first mark is for knowing that the triangle OAB is a right angle. Then your second mark is for knowing that the formula for the circle is x squared plus y squared equals r squared. Your third mark is for substituting in 3p and p. And your final mark is an answer mark.